but also taking into account the sort of potential threats that we're facing today as well. This requires a new security approach, really. Now, in the past, we've just added point products into the network. We'd maybe dropped a firewall into, demarcate our network border, and then maybe put an IPS device behind there to look for intrusion prevention, and then maybe added a filter for email or a filter for web. But all these, in the past, maybe have been regarded as point products, providing an individual role from the security point of view, with little intelligence between them all. So really, what we're doing with the secure access is tying these things together and moving from piecemeal security approach, from an architectural-based approach, where all these appliances, which were services for security that we're adding into a network, are providing a sort of unified threat mechanism, really. So a distributed security enforcement which can cater for all those virtual environments, mobile workers, and whatever device a user happens to be accessing the network from. So, and also providing an always-on security. So whenever a user, for example, is working on their laptop in the corporate office, you've got an acceptable use policy via a web gateway, which determines which web URLs they can look at. It has to be the same for the user when they go and work from home. So using certain security technology that we have, we can ensure always-on VPN connection, for example, so that when a user goes to work from home or remotely, they still fall through the corporate security gate, if you like, and acceptable use policy and the corporate security policy is maintained wherever they are. So those are a few things which we're addressing with SecureX, basically tying these solutions together to form a large unified system rather than just point security products on the network. Around that as well, providing greater visibility and control and enabling compliance, so providing some powerful tools to enable this security end-to-end for mobile users, for remote users, for cloud-based services, and tie that together from a management point of view as well. SecureX looks like this from a high level, and given the time we have this morning, I'm going to cover this from a very high level, but basically the building blocks to this are to take context-aware policy, to be able to determine a policy that a user has. By context, we may mean, taking into account time of day, taking into account where the user is, what kind of endpoint they're accessing the network from, what kind of privileges they have, or what AD groups they belong to, whether they're coming in by wired or wireless or VPN. That all forms context, which determines how we program or how we enforce using our context-aware enforcement, which may be integrated solutions, overlay appliances which talk to network devices which tell them how to let a user plug into the network. So in the case of our identity services engine, we can look at a user's endpoint, see what endpoint type they have, give them different access rights to the network depending on what their endpoint is. So what a user can do on a laptop, on a Windows laptop, they might not be able to do on an iPad if that's a brought-in device. So using that context-aware enforcement layer, passing policy down to the network layer, which might be a wireless LAN controller, might be a switch which the user is plugging into on the network. It could even be an email or web security appliance, which I'm going to talk about in more detail, and how that user accesses the network and what services they're allowed to look at on the network. In terms of content, that might be what kind of websites they're allowed to look at on the network. So tying together that context policy for the user into the network layer is what TrustSec is about. For this in the top, we have the Cisco Security Intelligence Operation, which is providing threat intelligence to all Cisco security technologies which are out there. SI key component of what we're talking about from an architectural point of view. The Security Intelligence Operation is a global intelligence database or operation operating out of the States, which has up to 500 threat analysts, 500 highly technical individuals processing global threats, seeing traffic coming in from all sources on the internet, seeing threat outbreaks, seeing virus updates, seeing reputation information for global IP addresses, and analyzing that to provide updates or signature updates or threat intelligence to the endpoints installed out there on the network. So you can see, for example, a Cisco IPS device which might be installed on a customer site, an adaptive security appliance, Cisco ASA firewall, VPN device deployed on a customer site, an e-security appliance and a web security appliance. All these devices can receive information from SIO and receive up-to-date threat information and be very dynamic in terms of blocking threat outbreaks in your organization. More importantly, we take information from our deployed global base of installed products on customer sites, sites or customer networks. So from mail and web perspective, for example, when you come an email or web security appliance, you can check a box which allows you to contribute back into SIO. So we have about 700,000 global sensors. We're seeing about 5 billion web requests a day. About 35% of global email traffic is going through appliances which report that information, that telemetry information, back into the SIO cloud. So a very, very active feedback, if you like, of global threat outbreak information, which we can process and turn back around and push that back out to our deployed base of appliances. And that's the power behind SIO, tying everything together to give us that sort of edge really against the hackers, against the malware providers, and ahead of the game really, and keeping the most dynamic, up-to-date profile on any given deployed appliance. Part of the security intelligence operation is Cisco Senderbase, which was gained by Cisco when Cisco acquired the IronPort email and web security organization. So, for example, when a user receives an email or when a user wants to access a website, we can take into account the reputation of that website. Senderbase is part of SIO, and our web security appliances and email security appliances can query Senderbase dynamically to find the reputation of an IP address which a user might be accessing a website on. So Senderbase will return a reputation lookup to a web security appliance, for example, and say this is from -10 through to +10 from a reputation point of view. If -10, we'll just block it. If it's 10, we'll allow it through. If it's somewhere between those areas, we might perform certain scanning on the return content to check that there's no malware infection in there. But that's how we're utilizing Senderbase, which is a very powerful mechanism for understanding, what spammers are sending email, for example. When we receive email into our email security appliance, we can quickly see that that's a bad or good reputation and block the email immediately. Whereas from a web point of view, we're interested in blocking a website based on reputation. Senderbase takes in information from these global feeds, if you like, including existing deployed Cisco appliances. So we have this is the largest and first of its kind globally, and as I say, about 35% of global email is exposed to Senderbase. So we have a very dynamic and up-to-date view of global IP addresses, public IP addresses, and what their reputation is. Let's go on to how we're providing these security services through various content security types. First, we're going to look at email here, in particular IronPort security appliances, and show you what email content security we have available. The web and email content security appliances are just two RU appliances, you see on the left there, which are quite a standard appliance, an Intel-based appliance running our own proprietary operating system, which is called Async OS. Async OS is providing optimized filtering and file transfer for both web and email content security. So very simply put, as you can see on here, the internet is sending in email, or it's returning web traffic to users and passing through an IronPort web appliance or email appliance, depending on what the content is. And that's happening in both directions. So incoming and outgoing traffic is passing through these appliances and being subject to the various mechanisms we have on there to detect and block malware. From a point of view, we can deploy that in a number of ways. So we can have on the right here simply a customer premise equipment appliance. So the organization buys the appliance from Cisco and has it on premise and manages it themselves. We can also have an on-premise appliance for email security shown here, which Cisco can manage for you if that's a requirement. If you don't have the skills or need to manage that internally, Cisco can take care of that management as part of the service. We also have a hybrid offering whereby we can host an email security appliance in the cloud, which is complementary to an on-premise email security appliance on the bottom there, the green one on the left. So for all outbound scanning of emails, for both content security, for malware scanning, etc., also email encryption and data leak prevention policies, that can be done on your on-premise appliance outbound. For incoming email, we see that first in the cloud and do all the reputation-based filtering and malware scanning in the cloud before we pass that on to your internal appliance. And that's how we can deploy it in a hybrid mode. A fully hosted mode, we can have a hosted email security appliance in the cloud without any premise appliance at the customer site, All that we're going to do is pass any email straight down into the groupware application, which might be Exchange, for example, or Lotus Notes. All in and outbound malware scanning, content filtering, etc., is performed in the cloud in the Cisco service. And we have dedicated hardware per customer in the cloud should you subscribe to that service. Those basic models of deployment for email security. When we're looking at virus scanning in email security, we have this multi-layer virus defense mechanism. So we firstly drop spam through reputation filtering. So anything that comes into the appliance will be first checked for spam through reputation, and we'll drop anything with a bad reputation, eliminating about 90% of all incoming mail, if you like. We then have on-box antivirus scanners as well from Sophos and McAfee, so you can deploy those on the appliance, and they will very powerfully work together to filter out any incoming malware attacks. Another interesting feature that we have, though, is for those viruses or malware outbreaks for which we don't have a signature yet. What if Sophos or McAfee doesn't know about a given virus outbreak that's about to hit your network? How do we deal with that? Well, use virus outbreak filters, and using Security Intelligence Operation Cloud, which I mentioned earlier, the benefit of that service is that it can push out dynamic updates to your appliances on your network, as I mentioned. In the case of virus outbreak filters, that means that we may understand in the SIO cloud that a virus is about to hit the internet, or a malware outbreak or worm, which is delivered via email, but we don't know much about it yet. We just know it's an executable file, and therefore we need to tell all IAM-port appliances to quarantine executable attachments if you're letting them into your network. So the virus filter is basically a filter received from the cloud from our security intelligence operation. In this case, it's saying at T0, in a day 0 outbreak, let's start quarantining zip exe files. As we learn more about that outbreak in the SIO cloud, we can start to narrow down what we're talking about here. It's something between 50 to 55K that we're talking about, so we'll keep everything else in the that falls out. Well, sorry, we'll release